finally, our last scenario is, imagine that you're given a mixture of 3 compounds, benzoic acid, triphenylmethane, and 4-chloroaniline. So in this thought experiment, I handed you a flask that had these 3 compounds in it, all mixed up, and said, can you separate these? So how would you do that using liquid-liquid extraction? And I kind of wanted to talk this through with some visuals. All right. So let's also kind of visualize what's actually happening in each step of this. Right. So we'll start out. We've got our 3 compounds, right? Triphenylmethane is right here. We've got 4-chloroaniline, and we have benzoic acid. Right. So these are all mixed up. What do we want to add? And there's some options over here that might give you a bit of a hint. What might we want to add to this mixture of these 3 compounds to start off?
We said we'd add an ether.
We were thinking.
Oh, sorry.
Go ahead.
Okay, so we add ether into the flask with our 3 compounds. Awesome. What would we do next? So now what would happen if we added ethers? We'd have these 3 compounds, and they would all be dissolved in the ether. Okay. So what we've done is we've taken our mixture. It was solid. Now it's dissolved, and we've got a liquid solution of our 3 compounds. What do we do next?
And then we'd add HCl.
Okay, so yeah, we could add HCl. And so remember that the HCl is going to be aqueous, right? And so we've got 2 liquid layers, right? The HCl and the ether. Which one would be on top and which one would be on bottom?
I think the ether would be on top.
Yes, absolutely. Okay. And prior to adding the HCl, right, all these would still be in there. And so now we've got our water layer with HCl on the bottom. Okay. And just to start out, they're not all going to fit, but just imagine that these 3 are all in the upper layer as well. Okay. So we add the HCl and we shake up our flask, right? And we want to vent it a lot because the first purpose of adding the HCl is to do an acid-base reaction. Right, so we're actually performing a chemical reaction in the flask, which can involve some gas evolution, right, and some minor exothermy potentially. So you want to be venting the flask, and you mix it up. So you set it down and you let it settle. All right, and so we've still got our diethyl ether on top, and we've still got our HCl on the bottom. Has anything happened to any of these upper compounds?
Would the 4-chloroaniline go to the bottom?
Exactly. Yep. So remember, this amine is basic, and so it will react with the acid to protonate, right? And now once it's protonated, now it's charged, right? And now that it's charged, it's become very, very polar. And water is very, very polar. So like dissolves like. Suddenly the 4-chloroaniline, from being a neutral organic that liked to be dissolved in the neutral organic ether, now it's polar, and so it's going to be happier in the polar water layer, right? So we do that separation. We can drain this layer out the bottom. Okay, and we can put it in a beaker. So we take all that out, we put it in the beaker. And then we're just left with our diethyl ether, benzoic acid, and triphenylmethane. What's the next step?
would we add water and sodium hydroxide?
Exactly. Just realized there's a typo there. Okay, so we add the sodium hydroxide and the water, and just as before, it's still going to be the bottom layer. Shake it up again, give everything a chance to mix and react and all that. And so what happens to these compounds up here?
The benzoic acid loses its hydrogen.
Exactly. Yep, so it's right in the name, acid, right? Sodium hydroxide's a base, so they will perform an acid-base reaction. The benzoic acid will lose its proton. Now, it's again a charged species, polar, goes into the water layer. So we can drain that out the bottom. Here. Let's make another beaker. Okay, so we take another beaker and we drain it out. So now we've got our 4-chloroaniline and our benzoic acid separated from our triphenylmethane in diethyl ether. Cool. So we've performed the separation, but you know, we weren't. I didn't ask you to get protonated 4-chloroaniline or deprotonated benzoic acid. So what's our final step here to recollect the solid compounds we started with?
Would you have to add like a base to the acid to neutralize it, and then like an acid to the base?
Exactly. Yep, so you take some more sodium hydroxide, right? And which flask are we adding this into? The chloroaniline flask or the benzoic acid flask?
The chloroaniline.
Exactly. Yep, so we add sodium hydroxide. It will neutralize the excess acid, and it will react with our 4-chloroaniline to reform the neutral compound. Now, this neutral compound doesn't like the water anymore, so it will probably solidify, and you can collect it from the water as a solid. In the same way, we add our hydrochloric acid to this other flask. It neutralizes the sodium hydroxide and reprotonates the benzoic acid. Again, you know, now we have a neutral compound. It will probably just solidify right out of solution, precipitate, and you can filter it and collect it that way. The triphenylmethane is in ether, which is very easy to evaporate. So you would isolate that by just evaporating away the ether with its low boiling point. All right. Any questions about any of that? Was that a helpful exercise to kind of visualize what was happening at each step?